What's poppin', dogs? Mr. Allen here, and we have ourselves some dope quadratic equations here in different forms. We got vertex form, we have general, aka standard form, and we have factored form. And we're just asked to find the vertex for each one. Well, let's start with that one, right? Easy, baby, easy. So the inside there, it's, remember, x minus h squared plus k, right? So that's going to be the opposite sign there. I'm going to have negative 3, comma, positive 1. The k value, that stays the same. There's my vertex. I'm done with the first one. Just watch out for the little whoop, switcheroo. You know what I'm saying? All right, moving on. Moving on. G of x. All right, we have a fancy little formula for this one. I have x equals the opposite of b divided by 2a. Not only does that get me my axis of symmetry, it also gives me my x coordinate of my vertex. So let's just do that. I got opposite of b, that's going to be negative 4 divided by 2 times a, which is 2. That means I'm going to get negative 4 divided by 4 is negative 1. So my axis of symmetry, just for fun here, is going to be x equals negative 1, okay? Okay? Because we could ask you for that. You could be asked for the axis of symmetry, the AOS. All right. How do I get my vertex? Well, I know, right now, I know the coordinate of my vertex, it's going to be negative 1, comma, something. How do I get that something? Perhaps I could use this fancy function here to figure it out. Well, I'll substitute in negative 1, right? I'm going to have 2 parentheses negative 1 squared plus 4 parentheses negative 1 minus 3. Negative 1 squared is just 1 times 2 is just 2. We got minus 4 and minus 3. So we've got negative 2 minus 3. That's going to be negative 5. There's my vertex. I got an x value. I plug it in and I get a y value. That's going to work for anything. Specifically here, we wanted our vertex. All right. Continuing. I got to swap them markers. We got blue now. We got ourselves factored form. So this is great for getting my x-intercepts, which would be, let's see here, x-intercepts would be 4, comma 0 and negative 2, comma 0, right? That's what I get from factored form. That's the easy part of it. But I want my vertex. So how am I going to figure that out? Well, if we do a rough sketch here, this is a positive, right? And if I had a rough sketch, I'd have positive 4 all the way over here and 2 right here. It's going to look something like that, right? This is negative 2. That's positive 4. Well, where the heck is my vertex going to be? It's going to be right here, smack dab down the middle there, right? Well, what's the middle of negative 2 and 4? If you can't figure it out and you don't want to count it out or whatever, you can just add those two together. Negative 2 plus 4, divide that bad boy by 2. Well, negative 2 plus 4 is 2. Divided by 2 is going to be 1. So not only do I have my axis of symmetry, once again, you guessed it, is x equals 1, my x coordinate of my vertex is going to be positive 1. Now I got to figure out that something, that y. How do I get that y? What did I do in the yellow one? I just plugged that bad boy back in. Let's do it again. All right, so I've got 4, parentheses, 1 minus 4, and then we have 1 plus 2. Also, you may have seen this before, function notation. People will often write h of 1 equals, right? Oh, I'm substituting 1 in, bro. Sorry, they got a little bit small. All right, so we got 1 minus 4 is negative 3. So we have 4 times negative 3. And then we have positive 3 right there. So we got negative 12 times 3 is going to be negative 36. Look at that. All 3 vertices. And some dope bonus information there. We got our axis symmetry. We got our x-intercepts. That's dope. We did a little bonus math. That's the best kind of math. But main thing was vertex from each one of these forms. Doesn't matter which one. You can still get it. It's just easiest with that pink one there. And that's why it has the name vertex form. You know what I'm saying? That's dope.